How's everybody doing? I'm doing pretty good. There we go. This is my first time doing a stream in a little while. And I'm doing a whole bunch of new stuff. So, also my first time really doing a programming stream. And I think I've got it set up in a way that's going to work. And I'm also checking my levels because this is the first time I've got speakers over here. I'm not using headphones today. And I think I've got it set up in a way that even that's working. Of course, I say that, and then the music's starting to get a bit weird. But I think that's just a me thing. Okay. So, also, new to me, we're doing a whole bunch of new stuff here, but there's a purpose behind it. So, I don't typically do Java and VS Code, and I've never really screwed around with VI at all. But as you can see, today we're doing all of that. So we've got the VI key bindings set up in VS Code just so we can learn them. And the reason we want to learn them, why do we want to learn them? Well, we've also got, eventually, we're going to transition to using NVim. I don't have the LSP set up yet, but it kind of works. Like, I can do stuff. Oh. Is it not lines? I don't remember the command already. But we're getting there. We're getting there. I know how to do stuff. I'm not one of those people who doesn't know how to close VI anymore. This is a good song. But as we can see down here, this is the mode that I am in VI, so like I can still be in insert mode or visual mode or whatever I need to be in. So we're going to try to learn them. It's going to trip me up. I'm going to screw up a lot. That's okay. So today is day one of coding in VI until the Primeagen notices me. Or I guess Vim, not VI, but close enough. So, what are we building? I want to make a chess analysis program. And it's going to take a long time. And it's going to be built in pieces, and there's going to be a big project. The first part of the project, though, is being able to... I was going to download an extension, and I didn't. But we will for next time. We're not going to do it today. This is a PGN file, which stands for Portable Game Notation, and it's how a chess game is notated. So I've been doing a lot of reading and looking up on how these are structured and what the different variations of them are supposed to be, and I want to make something that can parse these really fast. When I say really fast, hold on, I gotta put something on a speaker for one of my daughters. 1 second. My phone is just like dying right now for some reason. Or maybe it's just, nope. It's just the Google Home is screwy. Hold on. Oh, did that... No, it didn't. Okay. So, PGN notation. So we want to be able to slurp in about 1 million of these in like a second. Because we've got a lot of other stuff after doing the IO that we have to worry about. So I started messing around and I said, like, just like a quick doodle. Like if I were to just like write some code, like how fast could I slurp in like 250,000? So I found this file. That was probably a bad idea. It's really long. And it's got near 250,000 games in it. And I wrote 2 variations of an importer. So, is this the first one or the second one? This is the second one. So first variation we made, we started with strings, but strings are slow. And the reason strings are slow is because you got to keep making new ones, and every time you do a substring, you're also making a new string. When you do that a whole bunch, it's really slow. So how slow? Well, let's take a look. So we've got this file here. We're also just going to do it forever. The reason we're going to do it forever is just because the Java, the JIT, just-in-time compiler, it will optimize as it goes. So if we do it forever, we can kind of take a look and see over a little while what it actually looks like. So we're going to do that real quick so that I can bring you guys up to speed for where I got to. So as we're running this here, so get this going. So the numbers popping up at the bottom are how long it takes to process that entire file in seconds. So I mean, it's pretty quick, right? But look at what's going on with our memory. We're using a lot of memory, right? Like almost 400 megs of memory. And it doesn't get any better. Like I said, I just said a second ago it was going to get better, right? But it's not. So, stop that. So, we'll talk about that here. And again, I'm going to be slow at everything, right? How do I cycle tabs? Next tab. Next editor. File. Okay, hold on. Hotkey for tab. Swapping VS Code. Control tab. Oh. Okay. Oh, fine. That's fine. Yeah. So, what did we do in this that was so good or bad, right? So, all we're really doing is, we can forget about this. It's a model that I was working on. It's not quite done yet, but so what do? We just read the file in and we loop one line at a time. A line is a string. So like I said, we're making a whole bunch of strings over and over again. This is really messy. I did it really quickly, but we split the string. We look for where the moves start. So how I'm trying to parse this game, I know I'm kind of all over the place right now. I'm looking at everything, all the new windows and where I've put them. I'm trying to parse this into a tag and its value. And so I'm removing these. Actually, I'll just show you. There we go. So when this is done, I should have something that looks like this. That's what it should look like. This would be the label, this would be the tag. And I'm doing that for all of them. So I have to parse that. And then I want to be able to take E4 and E5 as separate moves. So separate plies of the same turn. So that means I need to parse out the move number and the spaces. And I need to continue doing that until I get to the end here. And then the next one is going to start with the tags again. Oh. I'm not going to save that. So that's what we're doing in this. First we say, do I start with an open tag and end with a closed tag? And that's an easy thing for us to say because we're reading one line at a time, right? So I read this line, immediately I say, do I start with an open tag? Do I end with a closed tag? And if I do, I'm going to split the string into based on the quotation. So that would mean this would be in one, and then this would be in the next one. And then there'd be more every time that there is one of those. So what I was doing was I was just echoing them out, but all I really care about is how long does it take me to get to here. That's all I'm measuring. I'm just measuring how long does it take me to get into the file, do what I need to do to get these pieces. I don't have to do anything with the pieces. I just want to measure how long it takes to get to that point. So I did check this and it does work. But when I run the really long one, it actually takes like several minutes because the printing out to console is actually really slow. And then we look for the moves. The very first move is always going to be denoted by one dot. And then when we begin to get into the moves, we're going to split the string based on the dot. And that's going to give us, again, we're working at the line level, right? So this is going to be in 1, 2, 3, right? And then we're going to split that based on space. And then here I had a little bit of logic to say like, anytime the length equals 3 in the array, I know I have a move set. So I would parse it out that way. Again, this isn't like the final result. We're going to rewrite that. That's what this is going to be, or a start on. And then we print out the time. So when we uncomment all this stuff, which we can do, and we can run the one game instead of the big one. Okay. So let's do that again. Okay. Oh, that's what I wanted. Whoa, yeah, we don't want to run it that many times. Hold on. There we go. That's better. What? Oh, I know what I did the wrong run. No? What have I done? Oh, I don't think I have Maven set up properly, so I think I actually have to do this. I think that's what it is. Like I just don't have Maven set up properly yet. Interesting. Oh, we're running the big one. That's why we never changed the file name. Dumb. Uh-oh. Can I cancel this? Uh-oh. Let's relaunch VS Code. Hold on. There we go. Okay. There's 250,000 games in that knee file, and the game file is the one that only has one. So that was the problem. So let's take a look at this. This is how it's actually parsing it out. So if we go actually look at this, I'm adding the colon in the code, and then we're just finding that. Okay, hold on. Again, trying to remember all these key combinations, new stuff. I'm putting them back together here. So I've isolated that these are always together in the array. And then when we get to the end, we're still fine. Because there's going to be two spaces in a row, and that's still going to split. So when we ran this indefinitely, we found that we could get it in like 1.6 seconds at the very fastest, right? So let's take a look at the second one. Oh no, we've got a guy here who's trying to sell views. Where's the ban button?
Fuck you.
Bye. I was waiting to use that. There. I don't know if it actually came through or not over the music, but add import. Okay. So in this version, again, this one's really gross, but it's a lot faster. In this one, we use a byte array instead. And we've got like a really big buffer just because I was trying to do it really quickly. So we are going to read in one buffer's worth at a time until we are at the end. And then we do a lot of silly things like looking for the open tag. Can I just hover over that? Will you tell me? Yeah. No, you don't. So open tag, close tag, a quote, a turn is denoted by a period, a space, and a new line. And then we got a bunch of booleans to keep us in check, and we're looking for indexes in this array. So when we get here, we say, is it an open tag? And I'm not currently in a tag. If so, set the start label. And then when we find a space, we're going to set the end label. When we find a quote, we decide if we're currently in a value or not, and then we set the end or the start or the end tag, and then same thing down here with the moves. But when we hit the end of the close tag, we only have to make these strings once, and we do it by copying the byte array. And then a similar thing, so now we're trying to find turns, finding the start index, getting to the end index, again making the two strings. So it's very similar, it's just this is kind of a bit harder because you're literally looping over a single byte at a time. So you can't do like split the string or like starts and ends with. You don't know where the end of the line is because you're just buffering however much data at a time and just going one byte at a time. So first we'll start with the looping version, and we are going to go to the profiling view again. So yeah, look at how much faster that is. Now, notice the memory stays a lot more stable. It uses that much because of how big the array is. So the way we're going to... Woo! Hey, Affinity. What's going on? We are trying to do really fast parsing things. I got a sound for you. We'll go with... Sure. Not nearly as good as...
But he came back.
34 months. That's almost 3 years. So currently that number that's popping up, that's how long it's taking us to effectively parse 250,000 PGNs. And we're going to rewrite it because I just did a quick doodle just to prove that I could do it. What I just kind of explained is like this one here, it uses strings and it does splits. Not fast enough, enhance. So this was the first one. And it used to take 1.6 to 1.9 seconds. So I lowered it down to 0.9. But I still think we can go faster. And I think we can do better. And I already know how I want to do it. I don't have a draw IO screen yet. Oh, wait, that's okay. Because we can do... hold on. We'll do new file. Crap. Draw IO. There we go. So what we're gonna end up doing here get it to 0.6 or we can't ship it. So rip. I think I think I can get there. So what I plan to do here is first we're going to do a pre-read. And the way that pre-read is going to do, what it's going to do, we'll do I don't quite know how I would do this as a diagram because I'm not actually going to do the loop. But like, I think we'll just go down and we'll just show it like this is what the pre-loop stuff is. So it's going to get start and end index for each game. And that's all we're going to do. We're going to get like a vector of some kind, and we're going to have the start index and the end index of every game in the byte array. So there's going to be a lot of math that's going to have to happen because we want it to be memory efficient. So we're only going to be reading like, I don't know, let's say like, I don't know, we'll benchmark it. I'm just going to pick easy numbers for now because there's not a good, let's say 1 megabyte. 1 megabyte at a time per read. We're still going to have to keep track of the offsets because the whole file is X many bytes long. So there's a lot of math that we're going to have to figure out, but it doesn't really matter for this picture. So get the start and end index for each game. This would be like the overall index, which is why I just explained that. So it would have to be like the start file, end file. We're going to have to keep track of the math for where each game starts and ends. And then now what we're going to do is multi-threaded game parsing. So that pre-read gave us everything we kind of now need to know so that we can just start multi-threading this. Because it really doesn't matter where they are, right? We know where the start and end is. If I start at the first game and then I give another thread the second game and I give another thread the third game, it doesn't matter which one's done first. Whichever one's done first is going to do the fourth game, and so on and so forth until I'm done. So as long as I'm only reading in like a megabyte at a time, the math can still work out. So like, it's going to be rough, but I think we can do it. It should be fine though, because this is going to be a single threaded process. It shouldn't reduce the per game speed. It'll make me process the 250K faster. Well, so that I will get to 0.6 because that 0.6 is for 250,000 games. That number that's popping up, that 0.9, that's for 250,000 games. Yeah. 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 No, this is really fucking fast. The string one was taking like 1.9 seconds. Yeah. Yeah, this is blazing. This is blazing. So the first one was using strings, right? So when we look at like a PGN like this, the file that we're actually processing is near 180 megabytes. It's around 250,000 games. The string version reads one line at a time like this, and it uses like, the first thing it does is it checks the start and end, and then it splits based on this, and then so it does a bunch of string splitting. Even when we get down into the moves, it's still doing string splits and regexes, and it takes like 1.9 seconds to 1.7 seconds depending on if garbage collection's happening and how well JIT's working. Which is pretty fast, but the second method is all using byte arrays, and this is a really gross way to do it. I just read in the whole file into memory at once. I just allocate way more memory than I'll ever need just so I can slurp it in one read, and I just start looking one piece at a time for these things. So right now it does nothing, but what it's going to do is we're going to save them into a Postgres database where I'm going to make something that searches faster than Chessbase. So right now, all we're measuring is just the pure read speed, nothing else. We're not even doing anything with it. So I commented out even the print lines to prove that I had isolated everything. This is just time to read. So there's still a lot of stuff that has to happen after this, which is why this part can't be slow. This part has to be ridiculously fast. And we're going to take the time and we're going to benchmark the shit out of everything, because this is not going to be made to be like extendable forever. This is going to be like a specialist thing where it's like, you might not be able to really change it a ton, but it reads, you know, 1 million games in like 2 seconds. And right now too, I'm out of my element because I don't typically code Java in VS Code, and also I've installed the Vim key bindings, so like I can move around by pushing J and K, and like B to go back a word, W to go forward a word. yeah, we're gonna struggle, but the way I see it is, depending on how fast I get the game parsing going, if I can parse the games on one thread and I can be writing to Postgres with virtual threads because I'm on Java 24, I can use one or two real threads to do the parsing, and several, like more, like 4 or 5 maybe, depending on how many it can actually spin up, virtual threads to do the Postgres inserts. But even then, there's going to be some hashing and stuff that has to happen as well. So there's going to be a balance where you kind of don't want... It's a blessing and a curse to read this fast, because when I can read this fast, I have to keep them in memory until I'm done processing them. So I'm probably also going to need to make a memory map, which is a part on disk that goes, I believe, it's kind of like a, if you picture it like IV caffeine straight into your veins, it's kind of like that, but data from the hard disk to the CPU. I got to do some more reading on it to fully understand it, but you can use a memory map like that to bypass RAM entirely and still get quick access to things. So we're probably going to do a bit of that because we don't want to fill up RAM all the way, but I think that's also going to be a bit of a fine line because you don't want to do a shit ton of temp reads on an SSD. So yeah. Oh, it doesn't go to the page file. It goes actually onto disk, which is why it's so useful. So what I want to do now is I want to write a better one of this. We now know that this was a good idea. So let's rewrite it to be a bit better. We're probably not going to get super far tonight. I just wanted to see if I could get the stream running, because I made a bunch of scenes for this too. So I've also got like a terminal scene for when we're in that. We're about to start looking at this, which is the PGN spec, so we can actually like ensure that we're making this to spec while we're going, the proper spec. We've got a profiling view so that we can see the JVM information. We've got a terminal and a code window, and we've got all of it together, and also just a desktop view and a debug view. So lots of cool stuff. I had to use this earlier. That was kind of fun. But we're gonna look at this spec for right now. We may not even get to coding today, because there's a lot of stuff we have to do. What I kind of want to do with streaming, I think right now, actually, you know what? Let's not name that crap. Let's can I? Oh yeah, I gotta. Here we go, folder. We'll make a docs folder, and we are going to see, we're also going to have to rewrite this a few times because we've got import from PGN, and then we're also going to want to be able to import from other known chess database types. So we'll leave chessbase for last because that one's going to be the hardest, but there's also SKID, which I believe we can, through open source, figure out how to parse those database files as well. But we're going to start with PGNs. So when we're writing this, this is why we're using Java, is because I don't want to learn how to do all the stuff I need to do in another language like Rust, or, I mean, maybe Python, probably Rust. But I don't want to learn how to do all this and figure out how to solve the problem. If I can solve the problem in Java and I can't get the performance I want, then I'll rewrite it in Rust. Is it spoilers Is that the mountain climbing game? Hold on. Oh, that game. That game. Okay. Okay. Yes. I know that game. The gun the gun talks to you. I'm cool with spoilers on that game because I probably won't play it, but I do like there's a lot of really good one-liners in it. Yeah. I will definitely watch that. Yeah, PGN spec. So we're going to look at this for a bit. We may not get to coding. We may just get some planning in. But what I want to do is I already kind of go down the rabbit hole and research things and like sometimes don't finish projects. But like I think that's fine, but why not just stream it? Because I like streaming. But I find that I don't have time to do things like this and stream and do other adult things. So if I can put this in streaming together, that's kind of a two birds, one stone thing for me. And maybe this will give me the accountability to finish some of these projects because I need some way to keep up my skills. So let's take a look at this. Portable game notation. We're not going to read every line of this. Like, I don't really care about the description parts up here. This one sounds interesting. The reasons for form. Yeah. So this is basically why this has to exist. And now this is the standard. Import and export. These are two different ways of formatting the same PGN data according to its source. The details of these two formats are described throughout the following sections. Okay, we'll get there then. Import data is rather flexible and is used to describe the data that may have been prepared by hand. Okay, that's fine. Should be able to handle somewhat lax input format. Yeah, we're going to have to. That's fine. The export format is rather strict and is used to describe data that is usually prepared under program control. That's fine. For a given PGN data file, export format representation generated by a different PGN program on the same computing system. Okay, should be byte for byte equivalent. Fair enough. That's fine. Speed of processing. The idea is to encourage chess rating software authors to always allow for at least a limited PGN reading capability. Well, mission accomplished. Reduced export format. Okay, it's just stuff that we can omit. That's fine. It's all in ISO. We don't need this today. We'll get to some of this stuff when we need it. There's no tab characters allowed. The line lengths cannot go over 255, which is good to know. Actually, no, that doesn't help us. That doesn't help us. We don't want it in lines anyway. We want it in games. Had an idea there. I was like, oh, well, we can just slurp lines, but no, we can't. And then there's commentary, and that can be denoted by a semicolon. So if there's a semicolon, that means that the comment is the rest of the line. And then there's also another way to do comments, which is curly braces. And if there's a semicolon in a curly brace, the semicolon loses its meaning. You can also escape things with a percentage sign. So like, there's a lot of more parsing we're going to have to do. But only to a point. We'll keep going through this and we'll come back to that. So tokens. White space characters, new lines, tabs, Some tokens are self-delimiting and do not require whitespace characters. A string token is a sequence of 0 or more printing characters delimited by a pair of quotation characters. Okay, an empty string is represented by 2 adjacent quotes. A quote inside a string is represented by a backslash and a quote. Okay. Non-printing characters like new lines and tabs are not permitted inside of strings. A string token is terminated by its closing quote. Okay. And a string is limited to 255 characters of data. That's not super helpful for us. I mean, it maybe when we're putting it on the database, we know that it's a varchar 255, but that's fine. An integer token is a sequence of 1 or more decimal digit characters. It is a special case. The most general symbol token class described below. Okay. A period character is a token by itself. It is used for move number indications. It is self-terminating. Okay. An asterisk character is denoted by itself. It is used as one of the possible game termination markers. Okay. It indicates an incomplete game or an in-progress game or unknown or otherwise unavailable. It is self-terminating. We've got the brackets, the parentheses, the greater than, less than token signs, the glyph notations start with a $sign. Symbol tokens. Okay. Okay, so here we go. Parsing games. So this is where we need to really pay attention. A PGN database file is a sequential collection of 0 or more PGN games. An empty file is valid, although somewhat uninformative. Okay. Fair enough. An empty file is a boring database. PGN is composed of 2 sections, the tag pair section, and the second section is the move text section. The tag pair section provides information that identifies the game by defining the values associated with a set of standard parameters. I don't know how I want to do that yet. I think what we're going to do is we're going to have the standard ones and then we're going to allow completely custom ones, but we'll probably have to store that in a JSON, which will mean that they're not like super indexable, but that's fine. The move text section gives the usually... Wait, what? The move text section gives the usually enumerated and possible annotated moves of the game along with the concluding game termination marker. The chess moves themselves are represented in standard algebraic notation, also described later in this document. Okay. So, the first thing that we're going to do, we're going to jump back into the code here. Let's figure out, before we start doing the reading, this was a model I was kind of working on, but I don't like it. I think what we're probably gonna do is we're gonna change all these into a map because we're just gonna accept anything. So a map of tags and a list of moves. So we are going to delete 6 lines, and we are going to, this isn't, I guess it can be fine, that's fine. And tags. I don't know how to do the organize imports on save yet. So we will get to that. Oh, shoot. Why is that jumping in so far? That's weird. Stop tags equals a thing that doesn't exist yet, but it will in a minute. There we go. I think we're just gonna do this. Yeah, X. This is. I gotta learn more VI stuff so that I can do that easier. Watching people who are really good at Vim, that kind of stuff's like so cool just to watch them do. You know, I think you also need to just do no. I guess I don't know if I can do. Yeah, I can do that. So we'll just do we are going to. Oh, relative line numbers aren't on. Oh, because of the type of file it is. Okay. Oh no, there it is. Okay. So we want 18. No, 9. And we want to pop into portable. Oh, case. Go. And then like that. Oh, wait. Oh, wow. No, that was a really stupid way to do that one. We can just do this. W. Yeah. X, W, D, $sign. Okay, and then J, B, B, X, W, D, $sign. Like I said, this is going to be really slow, but and then X, W, D. I got to get like a keyboard view going so you guys can see what I'm doing. Yeah, J is down. Well, I don't know why I keep not knowing that, but B. There's got to be a way to get back to the end of the line quicker. I said this earlier, but this is day 1 of using Vim, so the Primogen will notice me. We'll just do this every day until he responds. Hopefully by the time he actually sees one of the videos, I know how to use it. Oops. There we go. So maybe what we'll do is we're going to change this to standard tags. And then tags. Wait. Go. Oh no. Okay. I don't know what happened there. I got into a mode that I didn't want to be in. I didn't know how to get out. Standard tags. And then this is going to be like that. And then let's also have another map where this is the other ones. So this is custom tags. Gonna be that. $. Oh, nope. That's a DW. And then, yeah, custom, right? Whoa, can't spell. Okay. Go. I still reach for my mouse. That's going to be a rough habit to break. Let's next standard tags. Get standard tags. Tag, and we will do if. Okay, so this is going to be standard tags, tag, and return custom tags dot get tag. Wait, that's... No, that should be this. And this should be this. Custom tags. Get. Yeah. There we go. Perfect. And if okay, so we also need to also we need to support other ways of calling this. So if I've only got this, right? Oops. Whoa! That was the go live message. We'll just do this instead. Standard tags, because I don't even know. I think there has to be moves, so I'll have to go back and check here in a second. And I need the moves, right? And then this is going to be because I want it to be very clear, like I'd rather have these constructors than just YOLO it and have other people pass null, which by other people I mean me. And then this one here will be the other one. List of string moves. Oh, they're both map. Ooh. Well then. I didn't think about that. We'll just do this then. Okay. Then we do have to change this though. So we'll do standard tags equals no. There, that handles that. And we have to allow for moves to be null because technically an empty game is fair game, or an empty database is fair game. So No. List string. For array list. Oh, we're gonna do that. There we go. Okay. We are going to refactor that. Okay. You don't understand. Too hard. I guess I should have been watching YouTube chat too. Which part is too hard? Redundant typing expression. Okay, so because it returned. All right. I don't need that at all. Done. Even better. So that should be enough to get us started here. I don't know what I want to. I don't really like this right now, but it'll do. I mean, it's fine, but like, I don't know where. I think I need it to be a map because I want to be able to look up. I don't know if no, I don't need to look that up right now. When I'm looping through it, though, I need to know which move it was. So I wonder, do later versions of Java have tuples? I doubt it. No. Do they have... What about pair? Is that a thing? Oh. 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 JDK. Util. What is this? Oh. Oh. This is something complete. Oh, it's an XML thing. Okay. Not what we want. I don't know if we have access to any kind of pair that'll help us then. I don't think we do. No. Sure don't. That's okay. We'll use the list for now. We're not where we need to worry about that yet. So this should be fine. I can get my tags. I can is it okay to send those back as no? Probably. Did I not make it get custom tag? Did not. I think that's okay. Probably. Get custom custom tags. Okay. Now there are more standard tags than this, but that's all we're going to care about for right now. And if it's not one of these, then screw it. We also... We're going to screw with the casing. I don't think we are. Yeah. We won't. Okay, so we're gonna need this as well. Okay. Oop. Elo. Okay. Okay. And that's got a, yeah, that's good. Tag name. Whoa. Start tag name equals tag name. Oh, okay, fair enough. Fair enough. Okay. Get tag name. What?
And now we return you to the program.
There we go. Too many languages on my mind right now. There we go. There we go. Okay. Or no, wait. What am I doing? It should be get tag name from string. That's what I'm doing. That's why this wasn't making any sense to me. I was like, what am I doing? Get T dot. A thing that doesn't exist yet. So let's go make that first. So let get String. Yes. Tag name. Return. Tag name. Get. Tag name. Not equals. Tag. Return. T. And then let's do that for now. I know it's not pretty, but it will no quick fix possible for that, really? Okay. And bros. We'll just live with that for now. I know that other people maybe don't care about this, but this drives me batty. Ah, no. Okay. I don't know how to do that in how do I do that in VS Code? VS Code inline comment for formatter off. I'm not using prettier. The Red Hat one. It isn't as straightforward. Wait, isn't that what I did? Maybe the space is really important. No, that didn't do it. Oh, no, it's a colon. Ha, okay. Bang. I hate when enums don't look like that. Yeah, we don't need this. Okay. What don't you like? Field tag can be okay, sure. Okay. Bang. We'll separate this out later. This is just the first run at it, right? So maybe we don't get much further than this today, right? So we were looking at this here. So yeah, I was looking at this. Wanted to make sure I did it right. I've been working in Godot a lot. And I don't have any examples in my empty code base, and I don't have any snippets in my VS Code. But so tag pair selection. So yeah, we got these ones. Examples. Remove text. We will have to add all these. All of them. Opening designation from the new in chess. Okay. That's cool. Yeah, we'll add all those. More tags. I'm not worried about this stuff yet. It's like the nags and the comments and alternate lines we're just going to skip entirely. This is for reference databases. we're gonna keep the PGNs, but like we're not gonna do deep searching on, you know, alternate lines, I don't think. If you wanted to do that, I think what you would have to do as a user is you would have to like copy that PGN from moat line 3 to top line and then export that game to your reference database, because we want the reference database to be super snappy and like just as fast as possible. So let's design a bit of the pre-read, and that's kind of where we're going to get to tonight. So let's this is going to be the PGN importer. And what do we really need to do here? So we're going to do a pre-read. Pre-read to find start and end of each game. Okay. And this is going to be find. We'll be looking for the first open bracket. And then from there, this may change, but I think we're going to have to look for either... Oh, what was the notation? Oh, I'm on the wrong... Sorry, guys. What was the notations for result? There's 4. Where is the... There we go. 10, 01, half, and star. So we're going to be looking for this, or this, or this, or this. Yeah, that, or that, or that, or that. And then that is the end of the game. And that's where we're going to get to this, which is going to be end of file. This can come over to here. Okay. There we go. Give you guys a master class in how to make rough documentation that's not quite right, but gets the point across. Okay. So, you know what? We're going to do it this way instead. This is dumb. Okay, you go there. Oops. Boop. Grab those. You guys come over here for a minute. Go up this side. That's much better. And the reason we're doing this is because I might have to go a week, 2, 3, who knows how long between like actually like coming back to this and setting it down. So we want to make sure that whatever ideas we were talking about are pretty clear. So we're going to do a pre-read, find the first, or find index of next. We'll say next. Next that. Find index of last. There we go. Find the end of the game. Are we at the end of the file? No, keep going. Now, I think I lied a little bit here because I do think that we're gonna wanna, we don't have to talk about the buffering here. I guess we can put a note. That's fine. So, and then after that, once we have the whole start and end done, then we are going to multi-threaded game parsing, which is going to be we're going to have some kind of a queue or a map or a list, whatever, with all the games in it. So we'll say get game from queue. We'll call it a queue for now. It might not be a queue. Oh, that's the wrong box. So get game from queue. Parse tags and moves. Into portable game. Add game to completion. We'll say it's a completion queue. It's probably not going to be, but we'll say it is. And then next we've got the loop factor. Here we say more games. There is another game to process. We'll go get it from the queue. Do that again. Okay. And then we're going to say put to Postgres. Or no, we probably got to validate the games. Validate the games. There we go. Okay. You're just starting out, and you really think that you're doing a good job at like writing, code, maybe you are, but if you ever think you're doing a good job and you're not actually solving the problem before you code it, try it. Not saying you have to, but I think it's a completely different skill. And especially if your task is going to take, more than a day, there is value in charting out what you wanted to do or what you thought you were going to do. And then I don't know how we're going to validate the games yet, so I don't really want to get into that yet. But I think what I will put on here is after we validate the games, we're going to put to Postgres. And physical threads. And put to post multi-threaded. This is going to be multi-threaded as well. Multi-threaded. Put to Postgres, but this is going to be virtual threads. Okay. Actually, you know what? This is just for the yeah, we're gonna have to break this up another day, because I think I'm pretty much done for tonight. I just wanted to test the stream set out, or the stream setup, to make sure that it all worked. So it was kind of impromptu. But yeah, we kind of we got a little bit done today. We talked about how this is a brand new environment for me that I don't typically code in VS Code. On top of that, I'm learning Vim key bindings. So we will come back to this. We're going to see if we can finish this. So in closing, I'll just go over what we're building really quickly again. What I want to build is a chess database searching and comparing program that's at least comparable to ChessBase. I think I can do it better. And maybe this is going to be one of those things where I start going down the road and it's like, no. I just underestimated how hard the work was. But I want to see if I can be faster than ChessBase when searching millions of games for complex searches. So the first step to that is parsing the PGNs and coming up with a database layout that'll allow me to search fast. So I kind of have some ideas for the database design, and I can't really implement them until I can parse these games. So this is the start, is coming up with this portable game model that's going to have the moves and all the tags. We're not going to worry about the tags in the beginning for Postgres. It's really mostly just the moves. And where this kind of gets interesting is like we're going to be like fen hashing. So a fen string is an up to a 92 character string that describes everything about a given chess position, including whether or not en passant is available or whether or not castle rights are still a thing. So we're going to be storing these fen strings, but we're going to have to build them, right? So we've got this PGN, but the PGN doesn't really get us super far. So once we have this portable game, as soon as we start getting ready for Postgressing, we're going to have to start stepping through the game and generating the fen, which is, so this is going to be like a heavily multi-threaded process where we're going to try not to get too far ahead. So like we're going to do, I guess we kind of, I don't know how we're going to do it yet, but because if we read it all into memory, like we could be talking about gigabytes of space. So we may need to throttle ourselves a bit and do some locking so that we don't just kind of go crazy. But ideally, hopefully we can make this pretty darn fast. But yeah, we're gonna have to step through the game, create a fen for every position. We're gonna have to hash that fen, and we're gonna have to insert to multiple Postgres tables. And then once we have that, then we can start benchmarking the format and shape of the Postgres tables and just kind of try to keep reducing it down until we get like lightning fast searches. And we can do all that with CLI without ever making a UI first. So, yeah, it's going to be a long journey. I was kind of tired today. And again, we've got a new setup, but I did want to get started because sometimes you just got to start. I might be back tomorrow morning. We'll see. I have next week off from work, so I might do a little bit in the morning when I'm, because like this is all stuff that I'm doing in my spare time right now, like doing the researching. Like I've actually already read the document for PGNs, like I've skimmed it really quickly, and I've already, again, I had these, you know, draft import game classes as well. Yeah, this was fun. Like I said, we didn't get a ton done today, but that's okay. We will keep going, and next stream we will hopefully start writing the logic for actually parsing. We'll see. But that's all I've got for today, so I will see you guys another day. But one thing I'm going to do before I go is, if I can find it, I got a whole bunch of sounds, and we're going to stop VLC. We're going to stop the music. I really like these, so we'll play one.
If you have questions, then ask them. Fuck you.
They're great.
Yeah, it broke apart. Don't worry about it. It does that all the time.
I think we're going to be using that one a lot. Or this one.
Feels great to be doing stuff.
That's how I feel today. But yeah, you guys have a good rest of your night, and we'll be back another time.